So today we will study about states of matter, chemistry, right? States of matter. So let's see the first point. So, right, we know the properties of single particle of matter. It has atomic size, ionization enthalpy, electronic configuration, electronic charge, molecular shape, polarity. So these are the property of particles of matter, right? So particles of matter. So it has different property, like it has atomic size, right? Atomic size. Next one is ionization potential. Ionization potential or enthalpy. Next one is electronic charge density. Electronic charge density. Next one is molecular shape. Molecular shape. Molecular shape. Right. Next is polarity. So I will explain one by one. So see here. So we are studying about states of matter. Just now I have started. It is part 1. So see. So these are the properties of particles, right? First, Dalton told that atom is an smallest particle. Dalton's theory, right? Atom is the smallest particle, right? And further it is discovered that it also contains electron, proton and neutron. So it has subatomic particle, that is called electron, proton and neutron, right? So see here. So when any atom is there, suppose I am taking group 1. So group 1 means it has 1 electron in the last orbit. So its general electronic configuration will be ns1, right? So it starts from hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. So how to remember? So I will give it the mnemonics. So this is called He, Li, Na, Ke, Rab se Faryad. This is called Se Faryad, right? So H for hydrogen, Li for lithium, Na for sodium. These all are elements. These all are element. K for potassium, Rb for rubidium, C is for cesium, Fr for francium. This is called francium, right? So see here, as we move down the group, that atomic size increases. This atomic size increases. Why it is so? I will explain it. So as we know, atomic number of hydrogen is 1, right? So how to get the next atomic number? So I will give you the pattern, or that is called magic number. So we will follow that rule. So write 2, 8, 8, 18, 18, 32, 32. So now add the atomic number. So see, 2 plus 1 is 3. So you will get the atomic number of lithium. In the similar manner, you can get the next atomic number. So 8 plus 3 is 11. 11 plus 8 is 19. 19 plus 18 is how much? 37. 37 plus 18 is, so it is 5. 55. 55 plus 32 is how much? So it is 7. 87. Understood? So you can see that hydrogen contain only one orbit and it has one electron, right? In the similar manner, lithium will contain two electrons in the first orbit and one electron in the second orbit. Sodium, so 1, 2, 3. So last will contain the one electron and second will contain 8 electrons. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. And last will contain one orbit. In the group 1, each element will contain one electron in the last orbit. So you can observe hydrogen is containing one, lithium is also containing one, sodium is also containing one. In the similar manner, potassium, rubidium, cesium, francium. Right? So you can just observe that hydrogen contain one orbit only. Lithium containing 1, 2. Two orbits are there. In the sodium, it is 1, 2, 3. In the similar manner, as we moving down, so atomic size increases, right? So this first statement I have proved it. So please write up to this, then I will tell you the next point. So see, the next point is ionization enthalpy. So I will explain about it. So see, next topic is ionization enthalpy. So what do you mean by ionization enthalpy? So can you define, Ryan?
So it is the energy required to or remove an electron from the valence shell of
Good,
an
good.
atom.
So I will write the definition. The energy required to remove an electron from its valence shell or orbit, right? That is called ionization enthalpy. It's called ionization enthalpy. So you can see here, as we are moving down the group, so their size are increasing, right? Hydrogen, Helena के रब से फरियाद. So as we are moving down the group, atomic size increases, right? And orbits are also increases. So their last orbit electron is going away from the nucleus, right? So they are loosely bonded. So these are loosely bonded as we're moving down the group. So it requires less energy to break it down. Require less energy, right? To remove the electron. That is called ionization enthalpy. So here energy required is less, means its value will be less, right? Energy is measured in the form of joule or kilojoule. So this value, suppose it is taking 2 joule, or and upper one, this hydrogen electron is near to the nucleus, so it require more energy, right? And in the similar manner, this size little bit increased, so it require more energy. It has more energy of electron to remove from last orbit. is called ionization enthalpy. So these all are having highest energy required. These required less energy. So what we conclude? So when we are moving from top to bottom, energy required becomes less. Energy required become less. Right. So write this point. Now see the next point, that is electronic charge density. Right. So you can easily observe it. So as we are moving down the group, number of electrons are increasing, right? So hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. So this group we have discussed, right? I will take the next group. This is group is called 1. So please remember it. Mnemonic I have given you, right? So this will be helpful in S block. So next I will take for you is group 2, right? So it starts from beryllium, magnesium, calcium, strontium, barium, radium. So how to remember it? Beta, mange, car, a scooter, Bap Raji. Right. So it starts from beryllium, magnesium, calcium, strontium, barium, radium. Right. So as we are knowing that this lithium has in atomic number 3. Right. So you can observe in the previous slide. So it is having 3 atomic number. So beryllium is coming after that, right? So it will be 4. In the similar manner, in the previous one, this atomic number is 11. So it will be 12. If you don't know the previous one, how to calculate the next? So I will tell you the magic number, that is called magic number. So follow this pattern. So it is 2, 8, 8, 18, 18, 32, 32. Then you will get the next atomic number. So 4 plus 8 is 12. 12 plus 8 is 20. 20 plus 18 is how much? It is 38. 38 plus 18 is how much? 56. 56 plus 32 is how much? It is 88, right? So in this way, you can get the next atomic number. So third point we have to discuss, electronic charge density. Charge density. So you can see that when we are moving down the group, number of electrons are increasing. Number of electrons are increasing. So electronic density increases or electronic charge increases. So electronic charge increases. So please write this one. And remember this group 2. So group 2 having valence electron is 2 and valency will be plus 2, because they all contain 2 electrons in the last orbit. So they will lose the 2 electrons. So you can see here beryllium having 4 electrons. So it will contain 2 electrons in the first and remaining is 2 in the second one. Right. So this will lose the electrons. It will form B2 plus and 2 electrons will be coming out. Right. So loss of electron is called oxidation. Loss of electron is called oxidation. Right. So group 1 Group 2, they will lose the electron and do the oxidation and form cation. So plus sign is called cation. So metal forms cation, right? And they do the oxidation. So group 1 having oxidation state is +1. Group 2 is +3. Group 2 having +2. Group 3 has +3, right? In the similar manner. So please write this one. So you can write for other elements also. So do at home for the remaining. I will tell the next one. Like magnesium I am taking, it is having atomic number 12. So electronic distribution is 2, 8, 2. So it will lose the electron Mg2 plus and 2 electron will be coming out. So you can see here, these all group 2 will show the +2 oxidation state. Understood? So next topic is molecular shape. Fourth one. So it is molecular shape. So for if I discuss about the elements, then its molecular shape will be on the spherical in shape, right? When it is combining with another element, then its shape changes. Suppose I am taking group 13. So remember this group 13 also. It will contain the 3 electrons in the last orbit, right? So how to remember the group 13? So it starts from beryllium, manganese, boron, aluminum, gallium, indium, thallium. So how to remember? Bagan, alu, gajar in thela. So B for boron, B for boron, L for aluminium, Ga for gallium, In for indium, Tl for thallium. Right. So see here. So how to remember? I will write that. Bagan, alu, gajar in thela. Right. So we will use that magic number again here. So see, so I will write here 32, 32, then 18, then 18, then 8, then 8, then 2. So boron, for boron, I will give the atomic number that is 5. So how to get the next atomic number? You should add 5 plus 8. So it will be 13. 13 plus 18 is how much? So it will be 31. 31 plus 18 is 49. 49 plus 32 is, so it will be 81. So in this way, you have to get the next atomic number, right? So we are talking about that molecular shape. So what will be the effect on the molecular shape? Its size increases. For the boron, it will be 2 orbit only. For aluminum, 3 orbit, like that. So its shape size increases and shape will be spherical in shape for the element only. Size increases, right? Is increasing down the group. And shape will be spherical in shape for the element. Shape is spherical in shape, right? And it also increases down the way. So please remember this one.